Welcome to AP's Ophthalmology Pulse. Today we shall see why retinoscopy is performed at 1 meter distance. When considering refraction through a lens, points that form an object-image pair are said to be conjugate to one another. Because the paths of light are reversible, each point in a conjugate pair is the image of the other. The eye can be considered the equivalent of a single convex lens. If emmetropic, rays of light from infinity come to a focus at the second focal point, that is at the retina. So a point object at infinity gives rise to parallel rays, or rather parallel for practical purposes, that focus on the retina. The far point is defined as the farthest point at which objects are seen clearly when the eye is in an unaccommodated state. So, the far point is conjugate with the retina in the non-accommodated state. In emmetropes, the far point is at infinity, which for practical purposes in ophthalmology is at 6 meters. If the peephole of the retinoscope is at the far point of the patient, all the light coming from the patient's pupil enters the peephole and the illumination is uniform. So a uniform illumination is obtained when the peephole of the retinoscope is at the far point of the patient's eye. So if retinoscopy is performed at 6 meters in an emmetrope in the non-accommodated state, there will appear a uniform light reflex in the pupil that does not move with movement of the streak. Since no lenses need to be added, power of the patient is 0 or the patient is emmetropic. If the patient is myopic, the far point is at a finite distance between 6 meters and the patient, so the light reflex in the pupil will move with movement of the streak. Suitable lenses may be placed in front of the eye to bring the far point of the patient to the peephole. The power of the lens will directly give the refractive power of the eye being tested. However, since it is neither convenient nor practical to perform retinoscopy at 6 meters, it is classically taught as being performed at 1 meter and practically performed at arm's length or 67 centimeters. Because of this, a correction factor must be added. And so, for a working distance of 1 meter, the correction factor is +1, which is subtracted algebraically from the lens power that gave neutrality on retinoscopy. So the refractive power of the eye is equal to lens power minus +1. You can also say a correction factor of -1 is added to the lens power. You may use whichever terminology you are comfortable with. For a working distance of 67 centimeters, the correction factor is +1.5, and for 50 centimeters, that is for those with short arms, the correction factor is +2. In short, retinoscopy must be performed at 6 meter distance for the lenses needed to neutralize the reflex to be equivalent to the person's refractive error. A shorter working distance is selected for practicality, and hence a distance correction factor must be applied. So that's it for today. If you like what you saw, subscribe to my channel and hit the bell icon to never miss an update from AP's Ophthalmology Pulse. You may watch my other videos by clicking on the thumbnails. Please leave a note in the comment section if you wish for any particular topic to be covered in future. Look forward to regular updates. Thank you for watching.